Hello students, welcome to the class of physics. This is our second lecture of topic superposition of wave. In the last lecture we have started with what is the meaning of wave, what is wave motion, as wave is nothing but what? It is a kind of disturbance which is produced in the medium. Now next we have seen what is wave motion, what is wave pulse, and what are the common properties of wave. In common properties of wave we have seen what is the meaning of amplitude, what is the meaning of wavelength, time period, frequency, what is the relation between them. Next we have seen what will happen when a wave propagates, which kind of wave, like we have seen different kinds of wave like mechanical wave, electromagnetic wave. What is the meaning of mechanical wave? That is, we have seen the definition, which require material medium comes under mechanical wave. What is electromagnetic wave? Like which do not require material medium, it's electromagnetic wave. We have seen the example of mechanical wave, sound wave, water wave. These are the example of mechanical wave. And electromagnetic waves, that radiation, X-ray, gamma ray, beta, they all are the mechanical wave. Now and next we have seen what are the sounds, that is how sound propagates, which wave is responsible for the propagation of wave. That is, we have seen progressive wave, and progressive wave is contains transverse and longitudinal wave. What is the meaning of transverse wave? What is the meaning of longitudinal wave? Next topic, we have seen the properties of progressive wave. What property it has, that we have seen. Now today, I think in last lecture also I have started with superposition of wave. So today I'll start with superposition of wave. Now what is superposition of wave? When two or more waves traveling through a medium passes through a common point, each wave produces its own displacement at that point and independent of the presence of the other wave, and the resultant displacement at that point is equal to the vector sum of the displacement due to individual wave at that point. This is the definition of superposition of wave. So as displacement is a vector, the individual displacement are added by considering their direction. So there is no change in the shape and nature of the individual wave due to superposition of wave. And this principle applies to all type of wave like sound wave, light wave, waves on a string. And the best example of superposition of wave is when anyone uses headphone, one cannot avoid the background sound completely, because as we know, sound, the background music, that is sound waves are what? It is longitudinal wave propagating through an elastic medium. So when two waves traveling through a medium cross each other, each wave traveling in such a way that there is no other wave. So each wave behave that he is the only one who is traveling, there is no other one. So each wave sets the particle of the medium into simple harmonic motion. So thus each particle of the medium is set into two simple harmonic motion. Due to the two wave, the total displacement of the particle at any instant of time during traveling of this wave is the vector sum of the two displacement. So hence when even one uses headphone, one cannot avoid the background sound completely. So here in this case, two waves, one and the second, both are traveling and each wave produces its own displacement. So when they cross each other or when they superimpose at particular point, see here amplitude is maximum, here it is out of phase minimum. So the point they superimpose, at some point there will be maximum displacement, at some point there will be minimum displacement. So based on that, it is divided into two, constructive interference and destructive interference. So the constructive interference, when they will add together to produce a greater amplitude. Here before interference, this red one and blue one, red one traveling in this direction, blue one traveling in this direction. When they superimpose the green one, maximum displacement, that is their displacement is added. So once they will add together to produce greater amplitude, that kind of interference is known as what? Constructive interference. It is as we know, transverse wave have crust and trough. So this is crust trough. So downward direction, maximum amplitude. So these are the, or this is known as what? Constructive, when the amplitude is maximum, or when they will adding gives maximum amplitude or greater amplitude. Now next one is what? Destructive interference. This is considered the opposite of the constructive interference. When two waves moving towards each other, one have a positive and one is negative. One have a positive means upward direction, and one which is negative in downward direction, that is negative amplitude. So what will happen? One is positive amplitude, one is negative amplitude. As it is a simple harmonic motion, so the simple harmonic motion means for they having the same amplitude, same time period, same frequency, same amplitude. Means if upward direction it is plus A, so downward direction will be it is minus A. Magnitude will be the same, only direction is changing. So plus A minus A will be 0. So when they superimpose, when one is upward, one is downward, and during their superposition we'll get a minimum amplitude or smaller amplitude. Like here, one positive, this one is negative. During interference, they plus A minus A. Just I am giving the example, plus A minus A, or plus 5 minus 5. So we'll get the 0. So before interference, after interference, so here the amplitude will be minimum. Before interference and after interference, here there is a gap. So this is the minimum amplitude, and after interference again they will move it with their own speed. So when after adding or due to superposition, when the amplitude will become smaller, so that will comes under destructive interference. And once during superimposition, when their amplitude is added together and gives greater amplitude, that will be termed as what? Constructive interference. So here just we'll check with example. Here two waves traveling superimposition. So which point will produce constructive interference and which point will produce destructive interference? So if we see over here, the first point is point G. Now in this point, if we see point G, this is also upward direction, this is also upward direction. So these two gonna add. So once they will add, amplitude will become maximum after superposition. So this will term as what? Constructive interference. Now if we take the point H, here downward direction, and at point this same line it is upward direction. So here once they will add, one is plus minus, we'll get this smaller amplitude. Here I is also, take the point I, down, up. Here again we'll get the minimum amplitude. So this is destructive interference. For example, if it is 1, 2, 3, 4, and here it is 1 point something, or we'll consider 2. So 4 minus 2, amplitude will be the 2 unit. So this is destructive interference. And if see here, both are in the same direction. If 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, and here it is 1 centimeter. At this point, due to superposition, what we will get? 5 unit, that is 5 centimeter. So J comes under constructive interference, because once they will add, it will become greater amplitude will get. Now if we come to the point K, at point K if we see 1, 2, 3, 4 centimeter here, and is 1 point something, we'll consider 1. So 4, or we'll take 4 minus 1, or this is plus 1, this is minus 4 downward direction. So 1 minus 4 will be minus 3. Here we'll get the minimum amplitude. So this is destructive interference. Next point is L. At point L, if I consider 1, 2, 3, 4, and this will be again 1. So 4 minus 1, 3. Here it was minus 3, here it was plus 3. But it is minimum amplitude, because maximum already one wave is moving with 4. So 4 minus 1, it is 3. The value is getting decreased. So here again L is termed as what? Destructive interference. Now once when we'll come to the point M. At point M, 1, 2, 3, 4. Minus 4, and this is minus 1. So minus 4 minus, it will be minus 5. But it is negative. But though when we plot the graph here, this downward direction will get minus 1. So it is maximum amplitude. So when they add and we'll get maximum amplitude, that is termed as what? Constructive interference. Here again 1 2 3 4 and this is 1 5. Here we'll get the minus, so this is destructive interference. So constructive interference point G, J, M, N, H, I, K, L, O. I hope it is clear with the diagram how to find constructive and destructive interference and what is the meaning of constructive and destructive. So once greater amplitude after superposition will get constructive interference, and minimum amplitude of after superposition will term as what? Destructive interference. Now next we will see superposition of two wave pulse of equal amplitude and same phase. Now in this example amplitude were different. One wave having an amplitude of 1 and here one wave is having an amplitude of 2 centimeter. Here amplitude was 4 centimeter. Now if there is a superposition of two wave pulse of equal amplitude and same phase moving towards each other, what we will get? Or graphically we have tried to show that. So here in this case just see this diagram. One wave, one. After superposition they will add, amplitude will be maximum. So this is constructive interference. Now here in this case to show what will be the effect, so superposition of two wave pulse, here the propagation of approaching wave pulse, their successive position after every seconds, their superposition and their propagation after superposition are shown in this figure. Here successive superposition after every second is shown in the figure. Now the propagation, consider two wave crossing each other. Now consider two wave crossing each other. Here one wave and second wave crossing each other. This is at 1 second. So when they will cross, so it is two wave crossing each other between t is equals to 2 seconds at this point C or wave number C, and at t equal to 4 seconds. So we have to notice between point C and point E. So when two wave crossing each other between 2 equals to 2 seconds and t equals to 4 seconds, which is shown in the figure C, D and E. So here the two wave pulse superimpose, the resultant displacement is equals to the sum of the displacement is equal to the sum of the displacement, which is full line. See here, when two wave cross each other, we have to notice from point figure C to figure E. So here two wave crossing each other, so their amplitude gets added. So this complete line will be the maximum amplitude which is shown. Okay, so this is the maximum amplitude at t equals to 3 seconds. So two wave pulse superposed, the resultant displacement is equal to the sum of the displacement, which is shown in the full line. Due to individual wave pulse is shown like dash line. This is individual wave pulse. Due to superposition, at this point they will add. Okay, so the displacement due to wave pulse after crossing at t equals to 5 seconds. So once they superimpose, we will get the maximum displacement. Now after crossing 5 seconds, at t equals to 5 seconds and at t equals to 6 seconds. Again it is shown in the figure. So each crossing each other, both the wave pulse continue to maintain their individual shape. So here the two wave pulse superimpose. The resultant displacement is equal to the sum of the displacement, which is shown by the full line. This is the full line. Okay. Due to individual wave pulse. Individual wave pulse is shown by the dashed line. So this is constructive interference because their amplitude will become maximum when they superpose. So the displacement due to wave after crossing at t equals to 5 seconds. Once they will cross at t equals to 5 seconds, at t equals to 6 seconds, which is shown in figure number F and G. So after crossing each other, both the wave pulse continue to maintain their individual shape. After crossing, they will maintain their individual shape. So this is called as what? Constructive interference. Now the same we will see with destructive interference. Here one wave crossing, so opposite phase, they are in opposite phase, moving towards each other. So the propagation of approaching wave pulse, their successive position after every seconds, their superposition and propagation after superposition, again which is shown in the figure A to E. Okay, now these wave pulse superimpose at t equals to 2 seconds at the resultant displacement, which is shown in the full line, which is 0. Here full line is 0. Are differing in phase exactly by 180 degree. Here there is a phase difference of 180 degree. One is up, one is down. So here we will get phase difference of 180 degree. So this is destructive interference. Now displacement due to one wave pulse is cancelled by the displacement due to other wave pulse when they cross each other. And after crossing each other, at point C they are crossing each other. That is at 2 seconds they are crossing each other. And after crossing each other, that is after figure C, the wave pulse continue and maintain their individual shape. So this term under initially two wave moving opposite direction towards each other, one wave and this wave, they both are moving towards each other. They are opposite in phase, means one is crest so other in trough, so they are opposite in phase approaching towards each other. So here they are superimposing at t equals to 2 seconds. जब t equals to 2 seconds हुआ, they superimpose due to opposite phase. Suppose because they have equal amplitude, so here we are getting it plus a and here it will be getting minus a because they are opposite in phase. So plus a minus a will be 0. So we'll be getting a straight line here. Dash line is the individual wave का displacement दिखा रहा है. जो superimposition होगा will be getting a straight line because we will get 0. We will get 0. So at that point displacement is minimum. So this shows the destructive interference because they are exactly a phase difference of 180 degree. Okay. And in this case, after crossing this, they again move with their individual shape. So this is the example of destructive interference. Two wave pulse of equal amplitude and opposite force moving towards each other. And when two wave equal amplitude, same phase, here one upward direction, both are approaching. So at particular point they superimpose, will get the maximum displacement after crossing each other, means after 3-4 seconds they will maintain their own space, on speed, same speed. Clear? So this is the superposition of wave. Now what will be the equation, how to represent? So here we will see the amplitude of the resultant wave produced due to superposition. What is the formula, what is the equation of amplitude of the resultant wave? Means जब दो wave superimpose होंगे तो जो resultant amplitude मिलता है उसका equation क्या होगा, उसका expression क्या होगा, that we will see here. So for this we have to consider two wave having the same frequency but different amplitude. That the different amplitude be A1 and A2. Let this wave differ in phase by 5. Phase difference of 5 we have taken. This is will take 5. Okay. Now the displacement of each wave, we know the equation, general equation हम लोगों ने first lecture में देखा था. A sin omega t is the general equation to represent the simple harmonic wave. Now so we'll consider a two amplitude of the resultant wave due to superposition of two wave having different amplitude. So one wave we will consider y1. Y1 is the displacement in the y along the y direction. A1 sin omega t and y2 second wave A2 sin omega t plus phi. जो difference आ रहा है phase का वो इसमें add हो जाएगा because both having different amplitude. So different amplitude, so they will differ in phase. Now, according to the principle of superposition of wave, the resultant displacement at x is 0 is, we have to add the two wave. Okay, so at x equals to 0, we have to add two wave. Resultant displacement क्या होगा? Sum of the individual wave displacement. So resultant displacement at the origin, x equals to 0, at the origin y is equals to y1 plus y2. Now y is equals to y1, we will substitute the value of y1, that is a1 sin omega t, and at the place of y2 we will substitute a2 sin omega t plus psi. Now after adding a1 sin omega t plus a2 sin a plus b के फॉर्म में है, so we'll apply the formula of sin a plus b, sin omega t cos phi plus a2 that we have multiplied cos omega t sin phi. Okay, now here we have taken common sin omega t, so a1 sin omega t को हमने कॉमन लिया है, तो a1 plus a2 cos phi common sin omega t, and here a2 cos of omega t sin of phi. So what we have to do in this, we have to consider the two waves which have different amplitude and a1 and a2. Let this wave differ in phase of phi. One value we have considered the phase difference of phi. Now due to displacement of each wave at x equal to 0, we got two equations. What are the two equations? a1 sin omega t plus a2 sin omega t plus phi. सुपरपोजिशन में क्या होता है? दोनों डिस्प्लेसमेंट ऐड हो जाएगा, सो y1 प्लस y2. सो हियर a1 sin omega t we have taken and this will be a2 sin omega t plus phi. दोनों को ऐड करना है. sin omega t plus phi में हम लोग sin a plus b का फॉर्मूला लगाएंगे. a2 को समझो बाहर कॉमन लिया, तो sin omega t cos phi cos omega t sin phi, फिर a2 को हमने मल्टीप्लाई कर दिया, सो a2 sin omega t cos phi प्लस a2 cos omega t sin phi. ना यहाँ से हमने sin omega t को कॉमन लिया, सो a1 a2 cos phi sin omega t, a2 sin phi cos omega t. Now if we write a1 plus a2 cos phi as a cos theta, a1 प्लस a2 cos phi की जगह पे हम लोगों ने लिखा है, अज्यूम किया है a cos theta at the place of a1 plus a2 cos phi, assume it is a cos theta, and at the place of a sin phi we will consider a sin theta. Clear? a1 plus a2 cos phi की जगह पे हम लोग कंसिडर करेंगे, इसको अज्यूम करेंगे और टर्म a cos theta, एंड a2 sin phi की जगह पे we will assume a sin theta. So क्या एक्सप्रेशन मिलेगा? a1 plus a2 cos phi, ये हमारा ओरिजिनल इक्वेशन था, a2 sin phi cos omega t. यहाँ पे a1 plus a2 cos phi की जगह पे लिखा a cos theta, तो a cos theta sin omega t प्लस a2 sin phi की जगह पे a sin theta, so a sin theta cos omega t. Now a sin a cos theta or simply cos theta sin omega t sin theta, this is again in the form of sin a plus b, so a common sin omega t plus theta. So this is the equation of the resultant wave and it has the same frequency as that of the interfering wave. So the resultant amplitude A is given by squaring and adding. हम लोगों ने अज्यूम किया था a1 प्लस a2 cos phi, a cos theta, a2 sin phi, a sin theta. तो रिजल्टेंट एम्पलीट्यूड फाइंड आउट करने के लिए we will square and add. After squaring a1 plus a2 cos phi, स्क्वायर करना है a स्क्वायर cos theta प्लस a स्क्वायर sin theta, the whole square a1 plus a2 cos phi the whole square प्लस a2 स्क्वायर sin स्क्वायर phi. Now cos a स्क्वायर अगर इसमें से कॉमन लेते हैं तो क्या बचेगा? cos स्क्वायर थीटा प्लस sin स्क्वायर थीटा, cos स्क्वायर थीटा प्लस sin स्क्वायर थीटा इज इक्वल्स टू 1. तो क्या रिमेनिंग हो जाएगा यहाँ पे? ओनली a स्क्वायर, एंड इन दिस केस a प्लस b द होल स्क्वायर. सो विल अप्लाई a प्लस b द होल स्क्वायर फॉर्मूला, a1 स्क्वायर 2a1 a2 cos phi प्लस a2 स्क्वायर cos स्क्वायर phi. So here we will get a2 square sin square phi. Now apply, taking a this in the form of, we have reduced this, so what we will get, a2 square cos phi, a2 square sin phi. If I take the common a2 square, so what will remain, cos square phi and sin square phi, and cos square phi plus sin square phi is equals to what, 1. So what we will get, a1 square plus 2a1 a2 cos phi plus a2 square. This is the remaining. So this is the equation for resultant amplitude. Clear? So what we have done, first we have considered a two-wave, adding due to superposition, applying the formula of sin A plus B, taking common sin omega t. Once you will take sin omega t, substituting at the place of a1 a2, this was the original equation, a cos theta sin omega t, a sin theta cos omega t. This is in the form of sin A plus B. Now equation of resultant wave. To find the resultant amplitude, जो अज्यूम किया था, इनको स्क्वायर करना है और ऐड करना है. सो दिस इज ए स्क्वायर कॉस स्क्वायर थीटा, ए स्क्वायर साइन स्क्वायर थीटा, a1 plus a2 cos phi the whole square plus a2 square sin square phi. Taking a square common, in bracket it will be remaining cos square theta plus sin square theta, which is nothing but equals to what, 1. And here we will get a plus b the whole square का फॉर्मूला अप्लाई करना है. तो a1 square to a1 a2 cos phi plus a2 square cos phi, a2 square sin square phi. Now here again a2 square कॉमन लेते हैं तो cos square phi and sin square phi 1 हो जाएगा, तो what will remain only a2 square. So a will be equals to a1 square to a1 a2 cos phi plus a2 square. Now there are two cases. What are the two cases? When we will take cos phi equals to 0, that is the waves are in phase. When the waves are in phase, so phase difference will be what, 0 हो जाएगा. So resultant amplitude in that case, when two waves are in phase, so there will be no difference in the angle. The superimposed phase difference will be 0. So a1 square plus 2a1 a2 cos of 0 plus a2 square. Clear? Now what is the phi here? I'll show. The phi will be this. यहाँ पे फेज डिफरेंस है, तो जो ये फेज डिफरेंस एंगल बनेगा दैट इज दी फाई. ठीक है, कितना डिफरेंस आया, यहाँ पे दोनों सुपर इम्पोज नहीं कर रहा बिकॉज दे आर हैविंग द डिफरेंट एम्पलीट्यूड. सो जो एंगल डिफरेंस बनेगा दैट इज फाई. क्लियर? यहाँ पे सेम एम्पलीट्यूड था, जब ये दोनों सुपर इम्पोज करेंगे तो देयर विल बी नो डिफरेंस इन द एंगल. एक फुल कर्व बन रहा है. सो ये इन दिस केस ये और ये एंगल विल बी 180. So this is the phase difference. So case 1, when phi equals to 0, that is they are in phase. They are in phase मतलब दोनों एक ही सिंगल लाइन बन रहा है जहाँ पे एंगल क्या हो जाएगा, 0 हो जाएगा. So when we will substitute 0 at the place of phi, this is the equation we got. a1 a2 cos phi, phi phase difference 0 लिया है, तो cos of 0 will be 1. So what we will get, a1 square to a1 a2 cos 0 1 a2 square, a1 a2 the whole square, स्क्वायर रूट का इसमें से स्क्वायर रूट हट जाएगा, इट विल बी a1 plus a2. So the resultant amplitude is maximum when phi is equal to 0, that is when phase difference is 0. Okay, if the amplitude of the waves are equal, अगर एम्पलीट्यूड सेम है, सो a1 equals to a2 equals to a, then the resultant amplitude is maximum, which is plus 2a. Now when phi equals to pi, that is the waves are out of phase. When the waves are out of phase, in this case they are out of phase, so phase difference will be of pi, that is 180 degree. So once cos of pi, this is -1. So a1 minus a2 the whole square, square root से बाहर आएगा, it is will be mod of a1 minus a2 because we are considering the magnitude. The resultant amplitude is maximum when phi, sorry minimum when phi equals to pi, because यहाँ पे subtraction हो जाएगा. Now if the amplitude of the waves are equal, if a1 and a2 that is amplitude is same, then the resultant amplitude is minimum, and that will be what, 0. So we'll get 0. Now what will be the intensity? If you know the intensity, now there is a relation between intensity and the amplitude. Intensity is always directly proportional to square of the amplitude. जितना ज़्यादा amplitude होगा, the intensity will be maximum. So there is a direct relation with the intensity and the amplitude. That is, R is directly proportional to amplitude square. Okay. So when phi equals to 0, phi equals to 0 means what? They are in phase. Okay. That is a1 plus a2 the whole square. A square. A का value a1 plus a2. This is a square. a1 plus a2 the whole square. Now when phi equals to pi, that is out of phase. Out of phase a1 minus a2. This intensity is directly proportional to a minimum square, which is a1 minus a2. So therefore intensity is maximum when the two waves interfere in phase, while intensity is minimum when two waves interfere out of it. It's a very important derivation. So and very simple also. So what we have to do, we have to consider a wave. When we have started, we have to consider a wave having same frequency but different amplitude a1 and a2. If they have different amplitude, we have to consider they are different phase by phi. So one is a sin omega t, a2 sin omega t plus phi, the difference in the angle. Okay, so adding, taking common sin omega t, applying sin a plus b the formula, we'll get a1 a2 cos phi sin omega t, a2 sin phi cos omega t. At the place of a1 plus a2 cos phi, we will substitute a cos theta, and at the place of a2 sin phi, a sin theta. So once it will be added, a1 plus a2 cos phi, a cos theta, we'll get a cos theta sin omega t plus a sin theta cos omega t. So this will be a sin omega t plus phi. This is the resultant equation or resultant wave if they have the same frequency as of that of the interfering wave. Now to find the resultant amplitude, the one which we have considered a1 plus a2 cos phi, a2 sin phi, we have to square and add. After adding and solving, we will get a is equals to a1 square plus 2a1 into cos phi plus a2 square. Now here we will consider two cases. One case when phi is equals to 0, that is when they are in phase. When they are in phase, there will be a phase difference of 0 degree. Phase difference of 0 degree. So this is a1 plus a2. Okay, cos 0 1 हो जाएगा. This is in the form of a plus b the whole square. Square root say a1 plus a2. So amplitude will be maximum when the phase difference is 0. And the amplitude of two waves, they are equal. 2a, will get resultant amplitude as 2a. When pi equals to pi, that is waves are out of phase, the resultant amplitude is minimum because cos pi is minus 1. So a1 minus a2 the whole square will get a1 minus a2. So if the amplitude of the two waves are equal, that is a1 equals to a2 equals to a, then the resultant amplitude is minimum and it is 0. And what about the intensity? There is a relation between intensity and amplitude. Intensity is directly proportional to square of the amplitude, which is a1 plus a2 the whole square, and when it is pi, it is a1 minus a2 the whole square. So what is the conclusion? Conclusion is when intensity is maximum when two waves interfere in phase, and while intensity is minimum when two waves interfere out of phase. Clear? So I hope it is clear you all what is the meaning of superposition of wave, what is the type of constructive and destructive interference, what is the difference between constructive and destructive interference with the diagram I have tried to show you. Then next we have found the resultant expression for resultant amplitude and resultant amplitude expression for special cases. Clear? So therefore this is the conclusion of this is what intensity is maximum when the two waves interfere in phase, while intensity is minimum when two waves interfere out of phase. So this is the expression for amplitude of the resultant wave produced due to superposition. And the question for this may come like, derive an expression for amplitude of resultant wave produced due to superposition of wave, and also explain the condition for maximum and minimum amplitude. Okay, in this way question may come. Now, what are the conditions for maximum and minimum intensity for superposition of wave? There are 3 conditions, or we can say 2 conditions. First, we should know the relation, that is intensity of the waves are proportional to the square of their amplitude. So first, when phi equals to 0, I max directly proportional to amplitude square, that is a1 plus a to the whole square. And the second case, when phi equals to pi, that is out of phase, opposite phase, I max directly proportional to a minimum square, that is a1 minus a to the whole square. Therefore, intensity is maximum and the 2 waves interfere in phase, while intensity is minimum when 2 waves interfere out of phase. Clear? So in the next lecture, we will solve few numericals based on the topic which we have covered till now, and I'll start with stationary wave. Till now we have studied progressive wave. The progressive wave, the wave which is moving continuously. In that we have to give more importance on superposition of wave, its derivation, what are the types and properties of progressive wave. Clear? So I hope it is clear till here to you all.